Hi, this is Tom, and today we are going to talk about section 2.6. Section 2.6 in our text, and this is A equals L times U. Now, we know what A is. We know that U is upper triangular and that it's the result of A after a number of row operations. So let's begin there. Let's start with those row operations. Well, for the sake of just simplicity and clarity, we're going to work with A as a 3 by 3 matrix. The idea can be extended down to 2 by 2 and up to whatever you need. But we're going to work today with a 3 by 3. So if I started with the matrix A and I multiplied it first by E21, then I multiplied it by E31, and then I multiplied it by E32, the result would be the matrix U. Now, let's reverse this. So reverse this operation. Now, before we do that, I'm going to tell you, and we'll soon see, is that the matrix E, all the matrix EIJs, those are invertible matrices. Their inverse exist. So let's use that property. So if I'm going to multiply the left side, let's start with E32 inverse times, and I'm going to parentheses, times E32. Then we'll have the rest of these, E31, E21 times A. And since we multiplied by the left, on the left side of the equation, we also multiply by on the right side of the equation. So we have an E32 inverse times U. Now let's notice that this piece in the parentheses, this is just I. And so really now I have E31, E21 times A equals, now I'm going to leave a space after the equal sign, equals E32 inverse times U. And here's what I want to do, is let's multiply, do this the same idea. Let's undo the E31. So I'm going to undo it with its inverse, E31 inverse. So I do the same on the left-hand side, or the right-hand side, E31 inverse. Okay, and let's clean up what we've got. So now we have E21 times A equals, and we'll leave a space, and I have E31 inverse, E32 inverse times U. And then, you probably guessed it by now, what we're going to do is now on both sides, let's multiply by E21 inverse, E21 inverse. And look at what we've got now. Look at what we've got. On the left-hand side, we have A. And on the right-hand side, we have E21 inverse, E31 inverse, E32 inverse times the matrix U. We're going to call the product of those E's, we're going to call those, well, obviously, it's E inverse. We've called the product of the EIJs E inverse times U, but it has another property, and that's that the product of those EIJs, inverses, is always a lower triangular matrix, and we're going to use that property here soon. So E inverse is represented by the letter L. So A equals LU, and there we have it. A equals L times U. Now is the time to put this to work. Let's do this. We're going to find E inverse. And first we need to find E. So let's do this. For E21, let L21 equal A. For E31, L3, 1, let L3, 1 equal B, and for E3, 2, let L3, 2 equal C. First thing we need to do is find E. Find the matrix of E. Okay, so I'm going to pause the video, and I'm going to let you go ahead and put those pieces together, and then when you're done, come back and make sure that you got, actually, you know what, let's just do it together. That's silly. That's what we're here for. Let's do this together. You can work faster than me. That's fine. So let's try this. So E, the matrix of E is going to equal E, I'm going to write it this way, E3, 2, because that'll be the last multiplication that I'm going to do. So E3, 1 is 1, 0, 0, 0, 1, 0, and then in the 3, 1 position we have a B, and then a 0, 1. Times E2, 1. Well, that says that in the 2, 1 position we have the letter A. That's right there. So then the rest of it is like the identity matrix. 1, 0, 0, 1, 0, 0, 0, 1. All right, let's multiply these together. And let's see, I'm going to do this a little quickly. The first row is just the first row of the second matrix. So that's 1, 0, 0. The second row says, and let me use a highlighter here, this command says just copy the second row. So let's do that. That's just A, 1, 0. And then this third command, oops, I hit the wrong button. Let me undo all of that. A1, 0. And then this third row, B0, 1, says you multiply the first row by B and add it to the third row, and you don't worry about the second. Well, that's going to give me a B, 0, 1. And then, oops, and what I'm going to do is scoot this over. You should do the same. Just move it over, and we're going to put the E3, 2 in there. I forgot about that. I'm sorry. So let's put our E3, 2 into this position. Well, that's 1, 0, 0, 0, 1, 0. And this means that in the 3, 2 position, there's a C, 0, C, 1. All right, and then let's multiply these together and see what we get. So this first row says copy the first row. Okay, and the second row says to do the same. So we can write those really quickly. So I have 1, 0, 0, A, 1, 0. Now the third row takes a little bit. It says you take nothing from the first, you multiply the second by C and add it to the first. Well, that's going to be, I'm going to call it D for now. And let's come over here, because D is going to equal C times A plus B. So that's what's going to go in that D position. And then we're going to have a C and a 1. And that is the matrix of E. Well, then the next thing that we want to do is now let's find E inverse, which is also the matrix of L. Okay, and before I do that, the one thing I want to point out, and the difficulty, or I think the hidden difficulty or confusion about multiplying by the E's, is that by the time you pick up a third or a fourth or even a fifth E, notice what happens is that you get, it's not just the A and the C that we originally started with. They start combining each other, and so you get this weird one like this D. If this was a 4x4, you'd get more of these sums and products, or sums of products. So you'd be getting the results of row operations. So that's not very predictable, but let's watch what happens with E inverse. So we're going to find this with the augmented matrix like you would expect. We'll go do this longhand. So 1, 0, 0, A1, 0, D, C, 1. And my augmented matrix is with the identity of 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, well, what does this say? We start with row 2, and we're going to subtract A times row 1. So now I'm going to have 1, 0, 0, 1, 0, 0. And then my A minus A is going to be a 0, and then the rest will be 1, 0. And then over here now, I'm going to pick up row 2, which is 0, minus an A. So minus A, 1, 0. And then my last row is 0, oops, not 0. It's D, C, 1, 0, 0, 1. Okay, now let's work on the bottom left, the 3, 1 position. We'll do that by row 3, subtract D, row 1. All right, so that's going to give me a 1, 0, 0, 1, 0, 0. I'm just copying the first 2 rows, so 0, 1, 0, minus A, 1, 0. Okay, now, so then I have a D minus D, that's 0. I have a C minus 0 for C. Then I have a 1 minus 0. And then I have a 0 of a minus D, 0, 1. Okay, here's our last step. This is going to be a row 3 minus C times row 2. And I'm going to give myself some more space here. I've got, look at this scrolling screen. We have lots of space. It's time to use it. Well, now, I don't know about you, but I always have to be really careful that now I'm referencing row 2 instead of row 1. I often overlook that. I get stuck into looking all the way up to the top. Now, let's copy the first 2 rows. 1, 0, 0, 1, 0, 0, 0, 1, 0, minus A, 1, 0. 0. Now, C minus C is 0, and that was by design. Then we're going to have a 1 minus 0 for 1. There's our identity. Now, let's be careful here. So now we're going to have, I'm going to write this down below. We're going to have a minus D plus, and then we're going to have row 3, so it's minus D, and then we're going to have plus AC, plus AC. So that's the entry that's going to go right there. And we're going to come back and solve that in a moment. Then my next one is 0 minus C, and then 1 minus 0 for 1. Okay, and then let's work on this minus D plus AC. So minus D, well, D we said earlier, if it's back up here, oh, there it is, it's CA. It's CA plus B. So let's use that. So now I have minus CA plus B plus AC. Well, if you add all that up, that's going to just be a minus B. And let's put that into this position, minus B. Now, look at what just happened. So for the E21 matrix, remember what we said is we said that L21 was A. But look at what happened when we have the L matrix. Then what we had was we have a minus L21, or which equals A, or L21 equals minus A. And it worked in the L3 position, or 3-1 position. Notice that we started with L31 equals B. Oops, I should put it up here. We start with L31 equals B. But now, for the inverse matrix, we have minus L31 equals B, or we have L31 is minus B. And look, the 3-2 position, is now minus C. And it's that simple. That really, now you never really need to bother with the E's or multiplying them up, because you can put them together as their inverse matrix, and all it does is change the sign of the Lij component. So that's a big deal, because that saves us a lot of work. So what have we done and how do we use it? That's the question here. So I'm going to move up, and let's think about this. If I want to solve the problem ax equals b, well, I would multiply both sides of the matrix by e. And so I have EAX equals E times B. And we said that E times A is in fact U. So U times X equals, and we said that E times B is C. So then, well, now what do we have? Now we have this piece here that we also said that if AX equals B, but now we've done all this work. Where's that work? It's right there. A equals LU. So let's make that substitution. This says that LU times X is equal to B. But wait a minute. What is UX? UX is right over here. That's C. So let's make that substitution. So now this is L times C equals B. And that's how we're going to solve this next problem. So I'm going to scroll up, and I'm going to keep that there. I'm going to, oops, got some other scratch work down here. And here we go. The matrix we're going to solve, or the matrix equation is, or let me give it to you first as A. A is the matrix of, let's see, I had it here, of, this is by column. So by column it's 2, 2, 4, minus 1, 2, minus 5, 1, 2, 5. And what we need is we need L. And in finding L, we'll get U, we'll get U. So that's what we're going to do, is we're going to find, we'll go to U. Find U, which gives L. All right, there we go. So we're going to start with 2, 2, 4, minus 1, 2, minus 5, 1, 2, 5. And let's put this together. So my first operation is going to be row 2 minus, I'm going to put minus 1 just so we can see it, row 1. So that's going to give me, so I'm going to rewrite the first row, 2 minus 1, 1, 0, and then 2 plus 2, 2 plus 2, that's going to be, did I do that right? No, 2, and then 2, oh, gee whiz. 2 plus 1 is 3, and then 2 minus 1 is 1. There we go. And the third row is the same, 4 minus 5, 5. And then we're going to work on row 3. So notice again, our pivot is the 2, so we need the zeros down below. So I'm going to take row 3. I'm going to subtract 2 times row 1. Oh, that was a terrible looking arrow. 2 times row 1. So I have a 2 minus 1, 1, 0, 3, 1. Then I'm going to have a 4 minus 4 for 0. That's what we wanted. Then a minus 5 plus 2. That's a minus 3. Then a 5 minus 2 for a positive 3. We're almost done. And then our last operation is we're going to work on row 3. We're just going to add 1 row 2. So copy the first row. That's 2 minus 1, 1. 0, 3, 1, and then we're going to have a 0, and then 3 minus 3 is 0, 1 plus 3 is 4, and that's my matrix U. Okay, but it gets better than that. We know L. We know L as well. Because L is, I'm going to write the upper half. It's 1, 0, 0. And then we're going to fill in the 2, 1 position, then a 1, 0, and then we'll fill in the 3, 1 and the 3, 2 position. Well, the 2, 1 position just comes from changing the sign. So minus 1 becomes plus 1. Minus 2, this minus 2, we just change the sign on that for a 2. And then the positive 1, we change to a minus 1, and there is our inverse matrix. It's that easy. Okay, so now we're ready to solve. And let's see what our work did. Our work says to start here. Start with LC equals B. So this is where we're going to start. And before we start, I'm going to give us a B. And we're going to solve for B equal minus 7, 0, minus 17. Okay, I know that looks pretty rough, but I think we can do it. So here we go. We do this, we start with LC equals B. So 1, 0, 0, 1, 1, 0, 2 minus 1, 1. There's L times C, C1, C2, C3, and then B is minus 7, 0, minus 17. Okay, well now look at this. This works by back substitution, but now we're at lower triangular. So the first variable we get is C1, and we get that C1 is equal to minus 7. Okay, our next equation says that 1C1 plus 1C2 is 0. Well, we know C1, so this is minus 7 plus plus C2 is 0, so we could say that C2 equals 7. And then finally, our last equation says that 2C1 minus C2 plus C3 is equal to minus 17. Now let's use what we know. So this is going to be a 2 times C1 minus 7 minus C2, which is a 7, plus C3 has to be minus 17. Okay, I'm going to write this out or I'm going to make a mistake. This is minus 14 minus 7 plus C3 equals minus 17. Well, that's going to become negative 21. Move it to the other side. That's going to be 21 minus 17. C3 equals 4. Okay, now let's go back up. So hold on. C3 equals 4. And look at what we just found. We found that the matrix or the vector C is minus 7, 7, 4. Okay, let's go back up. Okay, so we started here. We found C, so this has been found now. But notice we have U. U is it's just hidden. It's just kind of sitting there, kind of nonchalant. There's U. We have U. We also have C, and so our last step is to utilize UX equals C. That's what we're going to do now. So here we go. So I'm going to pick up my U. I'm going to copy that for a moment. I'm going to put it right down here. And let's start working with it. So there's U. And then X, remember, is X1, X2, X3. And this is equal to C now. Well, C is minus 7, 7, 4. And so let's begin solving. So now, again, we're using back substitution, but this one's upper triangular, so we'll find the third variable in the vector first. So this says that 4x3 equals 4, so x3 equals 1. The next one says that 3 x2 plus 1x3 is 7. And what do we have? And let's use our x3. So this is 3x2 plus 1 equals 7. So this is going to be x2. I'm sorry, x2 equals 2. And finally we have 2x1 minus 1x2 plus 1x3 has to be minus 7. Well, we know x1, so let's see. So this is going to be 2x1 minus, well, what is x2? x2 is 2. Plus an x3, x3 is 1. So plus 1, this has to be minus 7. So then this is going to give us, well, minus 2 plus 1 is minus 1. Add it to the other side, plus 1, this is going to be a minus 6, I think. Yeah, so now what do we have? So we can say, so 2x1 equals minus 6, or x1 equals minus 3. And there we have it. And we have solved that system of equations, or that matrix equation. And we have x equals minus 3, 2, 1. Before we close this, let's go back to what we wrote. We wrote that A is equal to LU. And I want to write those down. L, and I want to show you what we're going to do is we're going to break U up one more step. We're going to write L as U as D times, it's going to be a revised U, so I'll give it a prime. And here's how it works. Let's find our actual LU. So our lower triangular matrix is right there. So let's copy that. I'm going to grab this matrix. Let's put it down here. And we want our U. Well, U, we said, our U is right here. Okay. There's A equals LU. And we want LDU, and I'll explain this. So L, I'm going to copy again, 1, 0, 0, 1, 1, 0, 2, minus 1, 1. Now, D stands for diagonal matrix, and that's all a diagonal matrix has, is it has elements on the diagonal, one in the top left, one in the center, since it's 3 by 3, and one in the bottom right. The rest of the matrix is just all zeros. 0 here, here, here. All of these are zeros. Times. Now, what this does is now we're going to multiply D times the U prime. So what that does is the diagonal is going to be the elements of this diagonal right there. So 2, 3, 4. So we can write those 2, 3, 4. Now, let's see how this affects the matrix of U. Well, it doesn't, U becoming U prime. Well, what happens then is, if I take out the 2, then I'm going to get a 1. And then I take out the 3 on the second row, that becomes a 1. I take out the 4 on the third row, that also becomes a 1. I still have my 0, 0, 0. But what it does is, it has the effect of taking and factoring a 2 out of the first row. So the first row now becomes minus 1/2, 1/2. And then the second row becomes 1, 1/3. And then then the third row becomes 1. And that's it. And so this is how you can make it diagonal. And we'll be taking a look at when that becomes even more special in our next section. Thanks for watching.